Okay, so this next section here on Trigo is on a particular application of Trigo, also known as bearings. Okay, now bearings is actually a form of telling you the direction of where to go. Okay, so for example, if I just tell you, you walk 300 meters, you reach the shop already. Okay, then your next question will be 300 meters, I walk where? Which direction do I walk? Do I walk straight ahead? Do I walk to my right? Or if you have a compass, you ask yourself, do I walk to the north? Do I walk to the east or somewhere in between east and south, for example? Okay, so the direction is very important. On top of telling you how far to walk, we also want to find a way to tell you the direction. Okay, but I mean, if you tried telling the direction to your friend over the phone, that kind of thing, right, you'll find that it's going to be a challenge, right? Because sometimes your friend asks like, hey, I cannot find you, where are you? Then you just say, oh, you turn left, you turn left, then you walk straight, then you turn right. Like, your friend will be like, which left, which right are you talking about? Okay, so it is very important for there to be a standardized way of telling people the direction. Okay, so bearings over here is one particular standardized way of telling people which direction to go. So that's why there are certain rules when you want to calculate the bearings of something. Okay, so I give you an example. The bearings of a point A from another point O. So basically the English here states that you want to start from O, you want to start from O and you want to go to A. That's your endpoint A. So where is the bearing of A from O? So from is where you are starting, A is where you want to go to. So you are standing at O, you want to go to A. Okay, so how do you find this bearing? You need to first draw or a north line and you start measuring from the north line. And how do you start measuring? You must measure in a clockwise direction. Okay, so the north line must be drawn at O and you measure in a clockwise direction. Clockwise, if you are not too sure, because a lot of you are just using digital watch now, clockwise is this direction. Okay, bearings must always be written as a 3-digit number. Okay, and if you need to give to one decimal place, you need to give to one decimal place, but it doesn't count towards the so-called 3 digits. So I give you a few examples here. So for example, the bearing of A from O in the diagram here. The bearing of A, so you want to go to A, but you want to start from O. So your O is the starting position. You start from O, you want to go to A. So you draw the north line at O. So there is a north line at O and you want to go from O to A. So the bearings is actually represented by this angle here. So you measure from the north line clockwise. So this is 50 degrees. So you write it as a 3-digit number. So instead of writing it as 50, you write it as 0, 5, 0, 3 digits. Okay, it's very important you know where is the starting point, where is the ending point, where to draw the north line and which angle I'm talking about. So you draw the north line at your starting position and you measure from that north line clockwise to where you want to go. Okay, so imagine now if you are standing at O, your friend tell you walk in the direction 0, 5, 0 degrees bearings. Then you will take your compass out, you go 50 degrees clockwise, that direction is where you want to head towards. Okay, now on the other hand, if I want to find the bearing of O from A, I switch the position of O and A. So you want to now end at O, but start at A. Okay, so the north line must be drawn at the starting position, which is now A. And you want to find out how to get to O. So you are interested in this particular angle where you measure from the north line clockwise. So this is the angle that you want to find. Okay, now this angle I labeled here is 230. Now, how did I get 230? Okay, so one thing that you will see that will keep appearing in a bearings question especially is that all north lines are parallel to each other, which makes sense. All the compasses point in the same direction. Okay, so all the north lines are parallel to each other. Okay, and once you have parallel, you should be able to see a lot of different angle properties involving parallel lines. So what do I mean by that? Okay, one thing you can do is, for example, I labeled here as well, see that there is an alternate angle here because north lines are parallel, right? Okay, so we know that this angle is 50. So according to your alternate angles, this angle here is also 50, which is what I labeled here. And hence the bearing that you want to find is 180 plus 50. Where did 180 come from? From here to here. Okay, then from here to here is 50. So this one is 50 degrees. This one is 180 degrees. Alternatively, you can see that these two, they form this angle and this angle, they form what we call interior angles. Interior angles means the angle in between inside must add up to 180. So this angle over here is actually 180 minus 50, which is 130. So the bearings that you want, the entire thing is 360 minus 130, which also gives you 230. So there are actually many ways to do it. The main thing is you must know that the north lines are parallel. Okay, so a few key things here. You need to know where is the ending and starting point. Okay, or where are the ending points and the starting points. Okay, where to draw your north line, which is always at the start point. How to find the angle is always measured in a clockwise direction from the north line to where you want to go. And you find the angle, please always remember to write it as a 3-digit number. Now, what do I mean by 1 decimal place? You should also write it as a 3-digit number. Okay, so a lot of times in Trigo, for example, let's say your answer turns out to be 50.156 degrees. Okay, usually 3 decimal place, right? Then let's say this is the bearings. Okay, you must write it as 1 decimal place, but this is not counted as a 3-digit number. Okay, your decimal place does not count towards the 3-digit. You must still write an extra 0 in front because this is what we mean by 3-digit number.